All right, so in this video, we're going to be going over the self-review test questions from the book for chapter 6. And I wrote these out and made some copies for the review session. So I just have these little halvesy pages that I'm going to use for the video here, okay? So these questions are on page 268, and there's essentially like one of each type of problem that you could see on your midterm for chapter 6 questions. So the first question here talks about tires, and it says the average tread life of a tire, okay, is known to be a normal distribution with a mean of 45,000 and a standard deviation of 2360. And so what I like to do at the beginning of a problem is I like to think about, well, what does that distribution look like? If it's normal, I know the distribution is unimodal and bell-shaped. The mean is 45,000. And then standard deviation is 2360. So if I take 45,000 and I add 2360, and I add 2360 again, then I can see what these would be on the number line. So I'm going to just include those for my distribution here. Again, if I take 45,000 and I subtract the value of the standard deviation, then I can get 1 standard deviation and 2 standard deviations here. I don't know that you really need more than that just for your general drawing here. This is just to help us figure out the other probabilities and what we're going to be looking at and give us some rationale here. But this is the population of tire tread life. Okay. All right, on part A, it's asking us to find what proportion or what's the probability that you have a tire that has between 42,000 and 46,000 miles on the tire. And so I want to think about on this number line here, 42,000 is going to be down here somewhere, okay, and 46,000 is going to be about here. So if I just draw like a little mini picture, where this is the mean at 45, 42,000 is going to be down here, and 46 is going to be up here. Okay. And so when I have a probability like this, when it's a normal model, I need to find the probability that x is less than or equal to 46,000. And then subtract out the probability that x is less than or equal to 42,000. And here's why. I'm going to pull up just another piece of paper to talk about, and here's why, okay? If I find this probability here, the probability x is less than or equal to 46,000. And this is 45,000, remember. Here's 46. That's going to find me everything below 46,000. If I find the probability that x is less than or equal to 42,000, here's 42, that's going to find me this probability here. And so when I subtract that, when I do the big probability minus the small probability, I'm going to find the probability that I want that's left over right here. So I'm going to find 2 separate z-scores, okay? But I'm going to find a first z-score for 46,000. So 46,000 minus 45,000 all over the standard deviation. Now, if I'm thinking about it here, it's going to be a positive number. My z-score is going to be a positive number between 45 and 47. So it should be a number, my z-score, between 0 and 1. And so let's do that. So 46,000 minus 45,000, and then divide that here, and I get 0.42. And z-scores, 2 decimal places make total sense, okay? I'm also going to find a z-score for 42,000. Now, 42,000 is to the left of the mean, and so my z-score, when I get 42,000 plugged into my z-score equation, should be a negative value. And that makes sense, and it should be like negative 1 point something because it's down here below 42,000. So 42,000 minus 45,000 divide by 20, the standard deviation, and I get negative 1.27. Now I want to go back to our big drawing here, okay? And so this z-score is 0.42, and this z-score is negative 1.27. And so if you use the book to go and find those probabilities, okay, 4.2 or 0.42, sorry, 0.4 over to 2, that's 6628. So this whole thing from here all the way down is 0.6628. Ooh, there we go. Okay, the probability of less than negative 1.27, negative 1.2 over to 7 is 1020. So this is 1020. So if I need to figure out what probability is left over, then I need to take 6628, so 0.6628, and subtract out that 1020, and I get about 56% here. For my answer. All right, on part B, it wants us to look at what's the probability of getting less than 38,000. Well, if you notice, 38,000 is actually more than 2 standard deviations below the mean. So when I draw my little example here, here's the mean, 38 is going to be like all the way down here. So that's going to be a really teeny probability, okay? And less than, so I'm going to shade to the left. So Z is equal to 38,000 minus 45,000 all over 2360. So 38,000 minus 45,000 divided by 2360 gives me negative 2.97 if I round. Negative 2.97. Okay, so the probability that x is less than or equal to 38,000, if I look at that z-score of negative 2.97 in a chart, I'm trying to get it under here, negative 2.9, and then over to 7, okay, you get 0.0015. So that probability here is 0.0015. Right, we're going to do part C together as well, and then I want to, part D is just like part A, okay? Then I want to talk a little bit about the calculator stuff. So if I want more than 50, so here's 45, 50 is going to be above 49, so 50 is going to be like up here somewhere, right? So let's find that z-score. It's going to be 2 point something. Okay. 2.12. Now, the reason I wanted to make sure we did something like part C is every probability you get in the table is a left-sided probability, and it shows you that in the diagram. Okay, entries in this table occur to the left of the z-score. So when I look up 2.12, put this down, okay, 2.1 and over to 2, I get 9830. Well, if you look at what we shaded in, that does not look like 98% of the graph. And that's because 98% of the graph is that left-hand side. I don't want that left-hand side. I want this side. So my p-value is going to be 1 minus that, which gives me 0.0170, which makes a lot more sense. Okay, one of the things I like to think about when I make these little mini graphs is like, should my probability be pretty big? Should my probability be pretty small? Is my probability going to be bigger than 50, less than 50? Is it more than half the graph, bigger than half the graph? You know, all of those things. So that way, when I get my final answer, I kind of have some justification that I'm doing it correctly. Now, in the calculator, you can do a lot of this as well. So if you go under distributions, the first things that pop up are PDF and CDF. And you're going to use CDF because it's for a continuous distribution function. And so that's why we use this. The coding's a little different than the binomial. So if you have a little bit newer software or you have a little like fancier 84 or on the Inspire, it actually pulls up a screen that says lower bound, upper bound, mean standard deviation. And that's because that's what we're going to plug in here. So for example, on part A, we always do lower bound, comma, upper bound, comma, mean, comma, standard deviation. Okay, and that finds the probability for us, and you can check your answer. Yes, that's what we got right here. Okay, the nice thing about the calculator is it doesn't round. Okay, like we rounded a lot in our answer, and it does not round. Also here for 38, so we go to normal CDF. Okay, my lower bound in this one is actually a really small number. So I have put like a negative, even though like negative treadwear makes no sense, but you just need like a really small number. So like -1 and like lots of zeros. So it's like really, really small. Then 38,000, 45,000, and 2360. And that gives us our same answer that we got here. Okay. For more than 5,000, you can do something similar. You just have to adjust it. Your lower bound is 50,000. Your upper bound is a really big number, okay? 45,000 and then 2360. And you can see we got that same answer there. Now, 12 follows from the same thing from part 11. So it says, suppose that we have 6% of the cars with the longest tread life, and they have at least X miles. So what this question is actually asking you to do is it's saying, if I know that this part right here, the longest tread life is 0.06, what is that X value that gives me a probability of 0.06 when I shade right here? Well, I need to be able to find a z-score. So on these questions up here, we went this way. We went X to Z to P. Okay? On these inverse questions, we're going the opposite way. We're going P to Z to X. Now, if you're going to look these up in your book, remember you need to look up the left-hand side. So we're actually going to look in our distribution table in the probabilities and try to figure out where 94% is. And so I'm going to look here. Sorry. Okay, 94% is going to happen right in here. Okay, and so if this is, let me grab a pencil since I'm writing in my book. Sorry. Okay, so 94% happens in between these two right here, right? So if this is going to be 0.94, I then have to track that up to here. And this is always a little bit tricky for students. So 94%, you want to think about this is 0.050, and this is 0.060. So the number that would be between them is 0.055. So the z-score associated with 94% would be 1.555. Okay, and another example today in the review session, I did 75%. So 75% would be 0.6 0.75 as the z-score. So let's go ahead and write that down. 94% was 1.555. So a z-score of 1.555 is what would give me that 94.6% split. I then need to solve that for x in context of my situation here. So I'm going to set up my z-score equation and then solve this algebraically for x. So the first thing I would do is multiply over here by 2360. So 2360 times 1.555. And then I'm going to add 45,000 to get my answer. Okay, and so x is equal to 48,669.80 miles. Now you can do this in the calculator as well. So if you go under distributions and go to inverse normal for your distribution here, your calculator settings though do require you to do the left-handed side. So if you just plug in 0.94 like that and press enter, it'll give you the z-score. And you can see we approximated that z-score really, really well. 1.555, 1.5547, which would round to that when we do the 3 decimal places there. Okay, you can also do inverse norm with the mean and the standard deviation, and it will find your answer for you. And you can see we're off by, I don't know, like what, 0.5 something, okay? But that's not a big deal. We're not worried about that. Okay, so on part B here, suppose 2% with the shortest tread life would have a tread life of at most x. So now I'm looking at 2% of the shortest tread life. So I'm looking down here and I want to know what's that x value. Okay, so let's just use this. So what's that z-score? Now because I want that left-hand side, I'm going to use 2%. Okay, that z-score is negative 2.054. And I'm going to say, okay, well then that's equal to x minus the mean all over the standard deviation. I can then multiply by the standard deviation, add 45,000, and I get that x is 40,153.15. Okay, I can then check that, 0.02, mean, standard deviation, and there we go. Okay, we did a pretty good job on that one. The last type of question that you're gonna get in a chapter 6 question is approximations of binomials using the normal model. So in this case here, we have a gluten sensitivity of 15%, random sample of 800 people selected. Now, in my opinion on this probability here for 115, I would just choose to do this binomial wise. So it's binomial because we have 800 people, that's our n. I have a gluten sensitivity proportion. And I'm looking within that n, what's the probability? Exactly 115 of the 800, okay, have this gluten sensitivity. And so I would choose, whenever it's an exact question, I would just do the binomial model because that's going to be actually the most exact. Okay, probability there. Now, back before we had such great technology in our hands, okay, you would have had to calculate each one of these by hand And they didn't even have like factorial calculators either. So like it made sense to use a normal model to approximate this because it just makes it a lot faster. And so what we're going to do is we're going to approximate this with a normal distribution. The mean is n times p. So if I take 800 and multiply by the probability, that's 120. And the standard deviation is the square root of NPQ. So N times P, and then Q is 1 minus P, so 0.85. Standard deviation of 10 point, I'm going to say 1 because that's going to round up, okay? You're then going to solve this like a normal model question like we've been doing with all of the other questions here with this mean and standard deviation there. So for example, let's do this one here. Let's do at least 170. So my mean, or 107. My mean is 120. Now 107 is going to be over here. And I want at least, so probability that x is at least that. So we're going to have a greater than. Now, when I shade this in, I'm thinking like, whoa, that's definitely going to be a probability greater than 50%. Okay, I'm going to calculate that z-score. (107 minus 120 divided by 10.1, and I get negative 1.29. When I use my normal model chart here, I get 0.0985, but remember that's over here. 0.0985 is over here. So the probability I want is the complement, and so that p-value is 0.9015. Okay. If I want at most 100, okay, so my mean is 120, 100 would be over here, okay? Now at most 100 means I want this side, right? Probability x is at most 100. So I'm going to find my z-score, 100 minus 120 over 10.1, 100 minus 120 divided by 10.1, and I get a z-score of negative 1.98. Now in this case, that is the side that I want, so when I go to look it up in my chart, negative 1.98 is 0.0239, so that probability is 0.0239. If I want to know what's the probability I'm between 111 and 123, so here's 120, 123 is over here, 111 is over here. I want this probability here. So again, that's one of those between probabilities. So I'm going to take the probability x is less than or equal to 123. And I'm going to subtract out the probability that x is less than or equal to 111. I'm going to find two z-scores, find those p-values, subtract them, and that's going to give me my answer here. All right, I hope that you found this chapter 6 review very helpful as you study for your midterm.